Assalamualaikum and hello everyone. Today we would like to present our topic, which is alkenes. In this presentation, we will explain the definition and use of alkenes. First, I would like to introduce our group member. My name is Tuan RAS1131A bin Tuan Abdullah.
My name is Muhammad Zarfan Nifail bin Sharudin.
My name is Muhammad Syafir Aswad bin Muhammad Sabri.
My name is Muhammad Arif bin Omar. First of all, I would like to talk about alkene. Alkene are a class of organic hydrocarbon contain at least one carbon and double bond. The common name for alkene is ethylene. IUPAC name is ethene. So we can see here there is a table of alkene and molecular formula, also structure formula. The first one is ethene. Ethene only got 2 carbon number. Also the formula is C2H4. So the second one is propene. The carbon number for propene is 3. The formula for propene is C3H6. And there is many more. So the next is physical properties. Ethene is a colorless, highly flammable gas with a faint sweet smell, lighter than air, with a low melting point, which is negative 169 Celsius, and boiling point is negative 104 Celsius. The appearance of ethene is colorless gas. It have a faint sweet odor. It is also extremely flammable and forms explosive mixture with air. The density of ethene is lighter than air. So the molecular weight is 28.05 gram per mole. The next one is chemical properties. Addition reactions. The pi bond in the double bond is weak, making ethene reactive atoms and across the double bond, breaking it. Hydrogenation. It adds H2 to form ethane. Halogenation reacts with chlorine or bromine to form 1,2-dichloroethane or 1,2-dibromoethane respectively. Hydration reacts with water in the presence of an acid catalyst to form ethanol. The next one is polymerization. Under heat and pressure, ethene molecules add to each others to form long chains, creating the plastic polyethylene. Oxidation. It can be oxidized by strong oxidizing agent like potassium permanganate, KMnO4. Then the last one is hybridization. Carbon atoms exhibit sp2 hybridization, forming 3 sigma bond.
Next is how the molecule is made in the lab or obtained from the nature. First, and human made. Ethene is obtained from a crude oil, primarily through a steam cracking of its heavier fraction like naphtha or oil gas. A process where these large hydrocarbons are broken down into smaller, more useful molecules like ethene by heating them to high temperature 715 until 915 Celsius with steam. After cracking, ethene is separated from the result mixture of hydrocarbon through repeated compression and distillation. This is how the molecule is made by human in the lab. Next, for the natural source. Ethene is naturally occurring gaseous hormone in a plant, where it plays critical role in various processes in nature. First is food ripening. It triggers the ripening process in climateric fruit like banana, apple, and tomato. The ripening happen when the fruit is almost cooked, and the ripening happen to the fruit. Next, the natural source is plant growth regulation. It is involved in seeding, sprouting, flower wilting, and the shedding of leaf. Okay.
Next, I will move on to reaction and chemical behavior of alkenes. Alkenes show specific chemical behavior because they contain carbon-carbon double bond. This double bond makes alkenes more reactive compared to alkenes. Firstly, alkenes are unsaturated hydrocarbons. For example, ethene is an unsaturated hydrocarbon because it contains a carbon-carbon double bond. This means ethene does not have the maximum number of hydrogen atoms. Due to the presence of double bond, alkenes can undergo addition reaction. In this reaction, atoms or molecules are added across the double bond, causing it to break and form single bonds. This is one of the main chemical reaction of alkenes. Next, alkenes react with bromine water. For example, ethene react with bromine water and cause the brown color turn to colorless. This reaction is commonly used as a test to identify alkenes because alkenes do not show this change. Alkenes can also undergo combustion reaction. During combustion, ethene burn in oxygen to produce carbon dioxide and water while releasing the heat energy. This reaction shows that alkene can be used as a fuel. Lastly, alkenes can undergo polymerization. In this process, many ethene molecules join together to form polyethylene, which is a type of plastic. This reaction is important in the manufacturing of plastic product. Last, in conclusion, the chemical behavior of alkene is mainly influenced by the presence of the carbon double bond.
Practical application. Industry use. Ethene is a crucial industrial chemical primarily used to make polyethylene and as a building block for other chemicals like ethylene oxide, with major application in packaging pipes. Next, agriculture, primarily used to control fruit ripening like banana, tomato, pears, for uniform market readings, induce flowering, promote uniform leaf fruit drop for easier harvesting, and even stimulate seed germination. Another technology, making synthetic rubber. Ethene is used as a raw material to produce chemicals like butadiene, which are polymerized to form synthetic rubber. Synthetic rubber is essential for car tires, hose, because it is flexible and resistant to wear. Lastly, medical sterilization of medical equipment. Ethene is used to produce ethylene oxide as a gas widely used to sterilize medical instruments such as syringes, catheters, and implants. It is especially useful because it can sterilize heat sensitive. Another technology